But we're going to be looking at today is we're going to be looking at simplifying radicals with variables. So kind of putting together what we saw about square roots or cube roots. But what if we have variables underneath our radicals? How do we handle them? We'll see. Pretty much it's very similar to what you've done earlier this week and last week, except basically we're just going to add like a step we're going to have to deal with like our variable part. So first thing you're going to do is create a prime factor tree for any coefficients or basically your number part. So that'll be just like you have been, what multiplies to give you what's above it. Once we've done our factor tree, we're going to put our primes and our variables underneath the radical, and I'll show you what that looks like. But then we're going to circle our groupings. Just a couple things. If you have a square root, you're circling groups of 2. If you have a cube root, you're doing groups of 3. And then something that's new, if you have a fourth root, you're going to circle groups of 4. And it would go, I mean, I don't know if I'm ever going to give you something other than these, but like if you ever saw a fifth root, I mean, you'd be circling groups of 5. So let's just get into some examples, but we'll see it's very similar to what we've seen last week and this week, except with variables, we just got to handle them a little bit different. So I'm going to kind of show you one way where you can write it out, or if you're able to kind of see in your head or be a little bit more visual, you can do it and save some writing. But for this first question, first off, it's a square root. So we're going to be looking for groups of 2, like our pairs when we're circling, but there's no coefficient or there's no like number part. So we don't have to do a factor tree. So x to the 6th power is really 6 x's. So if we were going to do this, you would circle, since it's a square root, like I said, we're going to circle pairs, so 2 at a time. So we have 3 pairs of 2 x's. So each one of these pairs would pull an x to the outside. So basically we would have 3 x's, or that would just be x to the 3rd power. And since there was nothing left in our radical, like once we pulled those pairs out, we don't have a square root in our answer. So this would be our final result. Here's how you could think about this. So that's one way you can do it. You can write out your variables. But another way you can think about this, like for example, number 2, we have 11 x's. Think about how many pairs can you make out of 11? Like you could count on your fingers, like 2, 4, 6, 8, 10. So that would be 5 pairs. So we would have 5 x's on the outside because we can't make a 6th pair because that would be 12. We don't have 12. So we have 5 pairs, and there was 1 x left over. Like because 5 pairs of x's would make 10, and then 1 x left over would make 11. So that's how you can think about it if you don't want to write it out, or if it's helpful. I mean, you could write out 11 x's. So that's 5. That's 10. That would be 11. But you would see if you circle your pairs.
But I got a question. How did you get x to the 5th?
Because that's how, like what I'm writing here, like see how there's 5 pairs? So that's like you would be able to pull out 5 x's. And then this x.
Of x to 11?
Say that one more time.
So you get x out of 5 to x out of 11?
So either one of these methods, it's up to you. Sorry if I paused the video there, so if it kind of seems disjointed. If anyone's watching this Zoom video later. But you can either write out your x's or you can kind of count on your hand, like how many groups am I going to be able to make? And then how many x's are left? That's going to be kind of what you're thinking about. But this would be your answer either way. So let's look at one where we got a number part, like a coefficient and a variable. So for like problem 3, it's going to be very similar, except you're going to do like your factor tree. Let me zoom in a little bit. Come on. Sorry. All right, there it goes. So think of two numbers that multiply to 100. So, I mean, you could do 50 and 2, you could do 10 and 10, you could do 25 and 4, 20 and 5. Like, so, I mean, whatever you think of, I'll just do 50 and 2. But as long as it's mathematically correct, it doesn't matter. 50, maybe I'll do 10 and 5. That would be 5 and 2. But no matter what pairs of numbers you pick, like as long as it multiplies to the number above it, I mean, like as long as you didn't pick like numbers that don't work, you will get the same final answers at the end. So for number 3, we have, just looking at my number part, I have 2 2s and I have 2 5s. So that's my like coefficient part. For my x part, I have 6 x's. So if you want, you could write them out. And sometimes it's hard to squeeze it in, so I kind of just like make more than one row of them. So that's 6 x's right there. Since it's a square root, we're circling pairs. So I would circle a pair of 2s, pair of 5s, one pair of x's, another pair of x's, a third pair of x's. So then we're going to pull these to the outside. So I'm going to pull out a 2 from that first group, a 5 from that second group. And then since I have 3 pairs of x's, I'm really pulling out 3 x's. Or if you multiply this out, it would be 10x to the third. Because x to the third means you have 3 x's. Since there was nothing left over, like everything inside of here was circled as a pair, there's nothing left over, we won't have like a square root part in our answer. Like this is our final answer. So if it's helpful to write out the variables, do it. Or if you can count on your hands, like for example, you have 6 x's, that's 1, that's 2, 4, 6, that's 3 pairs. Nothing's left over, so you were able to pull 3 x's out. So I don't know if it makes sense to kind of think of it like that, or just write it out like I'm doing, like I did on like the work in this question. But how about you guys try number 4? So like the first thing you're going to do is do like your factor tree. So break down 32. Then once you got that, write your prime factors underneath your root, and then think about your x's, either kind of count out how many pairs you can make and how many would be left under, or write out 13 x's and circle your pairs. Like I said, I would recommend maybe you write it like as a couple rows like I did here, because it's hard to like 13 x's is going to be pretty long. So might help to do like a couple rows or more, but give this one a shot. But going over number 4, so if you did your tree, and your tree might look different than mine, but you could do 16 and 2, you could have done 8 and 4, you could have done, I think that actually might be it, but I could be wrong. 16, you could do 4 and 4, you could do 8 and 2. Either way once you break this all down, no matter, like, I mean, as long as you're mathematically correct, you should get that you have 5 2s. Don't forget about this 2 up here. Sometimes it's an easy thing to do. So we have 5 2s. And then we have 13 x's. So if you want to write them out, like I said, especially don't be afraid to make multiple rows. And since I know it's a square root, I'm circling pairs. I want to kind of group them up by like an even number. So like I wouldn't put like, I would try to avoid putting like 5 at a time, like do like groups. So it's easy to circle them. But that would be 8. That would be 12. And then we have 1 left over, like from so if we circle our pairs, we got 2 pairs of 2s, 1 2's left behind. For our x's, we got 1, 2, 3, 4, 5, 6 pairs. So if we write our final answer, we're going to have 2 2's on the outside, 1 from each one of these pairs. If we count our x's, we have 1, 2, 3, 4, 5, 6 pairs of x. So if you want to just write that as x to the 6th power, and then the square root, well, what was left behind? Well, we had a 2, and we had an x left behind. So that would just be 2x. So if you just multiply this out, that would be 4x to the 6th square root of 2x. Any questions so far? And if you're able to do like anything like where you don't need to write out as much, like maybe you're starting to see some things in your head, you're welcome to skip. Like for example, the x part, like if you could kind of visualize in your head, you have 13 x's. Well, how many pairs is that? Well, count on your fingers by 2. So 2, 4, 6, 8, 10, 12. Like if you're counting on your fingers, that would be 6 pairs. But 12 x's, that means we would have one x left behind underneath our root. So if you're able to do it without writing it out, go for it. But I mean, writing it out, it's not a big deal. It doesn't take that long to write out 13 x's. It's kind of annoying, but it doesn't take that long. So those are our first 4 examples. So problems 5 and 6, same idea, except we're looking at cube roots. So, sorry, I got something in my eye. All right, so looking at example 5 and 6, we're going to be looking for groups of 3 because the cube root. So like when we're circling, we're not going to circle 2 things, we're going to circle 3 things. So this first one, we just have variables. So if it's helpful, you could just write it out. But we have 1, 2, 3, 4 x's, and we have 10 y's. So that would be 10 y's right there. So since, like I said, since it's a cube root, we're circling groups of 3. So I would circle 3 x's at a time. So 1 x is left behind. For my y's, I kind of wrote it like this on purpose. I tried to make groups of 3, but we can make 3 groups of 3 y's. So when we write our answer, we're going to have 1 x. We're going to have 1, 2, 3 y's. And then that's it. And then what was left behind? Well, we had an x and we had a y. So it would be x, y. How about you give number 6 a try? I mean, so here, I'll just do it really quick, but I mean, you would just do your factor tree. So your number part, you just have 3 2's, but see if you can do your x's and your y's and see what would pull out. But give this one a try. Recorded. So this is what your answer should be for number 6.
Please do not tell me we have a delta math on this.
You won't have a delta math. Let's look at one more example, and then we'll be done with our notes, and I'll kind of explain what the rest of this week will look like.
Yeah, this confusing me.
It is a little bit tough, so we'll see. And if you have questions, like if you have any questions as we're going through it, let me know. Like this is the last one, but I mean I can go back or I can make like a new problem. We could look at some more. But the only other thing I wanted you to see is if we have a 4th root, like if you see like a little 4, like on the inside, like instead of like the 3, that means you're going to be circling groups of 4. So if you were like, so if you were doing this problem, I mean, you would just do your factor tree like you normally would, whatever you want to do. And like I said, your tree could look different than this, but you should still end up, if you break down 16, with 4 2's. So if we rewrite, this is called a 4th root when you have like a little 4 on the outside, but we would have 4 2's. And then we have 5 x's. So since it's a 4th root, we're going to circle groups of 4. So like the answer to this question, we could pull out a 2, we could pull out an x, and then the only thing left behind was one of our x's. So that would be our answer.